Good morning, sir. Good morning, ma'am. I'm Anand Dharmapuri, Director, Orbit Communication Systems, Israel. I'm here to give you an overview of maritime SATCOM systems, airborne SATCOM systems, and a short presentation of the land SATCOM systems. Today we also have a SATCOM live terminal. I would request all August audience to go and have a look at it. It's the VIP parking area where we have a system which is along with our partners, Elcom, which is a technological partner in India, and Viasat Constellation. This will be the first time that we have a Ka-band 30 centimeter SATCOM system live available as a demo in the parking area. With that, let me go around and tell you about it. Orbit is based out of Israel. It's an R&D and a completely FINI. It's the main investors. It's a company which has been it will be completing 75th year next year, started in 1950. And we have the complete in-house development and R&D production of all the systems and solutions. What we have is basically in the three segments: the air segment, the maritime, and the land segment. In this is what you see. The numbers are the install base, the number of systems that are already existing across the globe. I would divide the entire defense, I would say the portfolios, the business lines, into three segments. One is the airborne segment. Airborne segment, this is where we have a very niche product, which is part of all the fighter aircrafts, whether it is C-295, whether it is a F-14 or F-16, Rafale. The airborne communication system, which is basically used by the fighter pilots to the co-pilot and the other members inside the aircraft, is from the orbit. This is one niche area, and we have also given these particular systems to our Indian Air Force AEW aircrafts. The second segment, which we are of more interest to our audience out here, is the SATCOM systems. So in this, I will segment into three parts: that the airborne segment, and the maritime, and the land segment. All the three segments, we have a very wide presence across the globe. If you're starting with the airborne, I'll cover in a later slides. Maritime, we are already there, more than 25 navies across the globe. And land, we already have a demonstration and the systems available for field-proven systems available for use. The other segment is a ground system segment. This is a tracking and telemetry. And the large antennas, which are size of 2.4 meters to 11 meters, which are used for Earth observation systems. We are exhibiting at F7. If anyone is interested in those, I will be very happy to share that. For the time limitation, I will restrict my presentation to SATCOM systems for the thing. Our customer base across the world, we have a large customer base. Also in India, we've been working with ISRO, been part of the Indian Navy for the last more than 14 years, and other navies and other companies across the globe. What is the capabilities, or I would say the core values of Orbit? Basically, we are a system engineering and a product and a solution provider with a very high reputation of innovativeness in the RF and a complete product which is field proven. The solutions are of the highest innovative nature, and continuously there is a development and R&D investment of more than 20 to 30%, which ensures that we are always at the state-of-the-art technology. This is our presence all over across the globe. I'm operating from India. I take care of the Asia Pacific up to Australia and New Zealand. And we have a Singapore partner out there, and we have rest of them. We have another office. The main office is in Israel, and we have one more office which is based out of US for the US market. Coming to the core subject today of discussion is the maritime SATCOM systems. Maritime SATCOM systems, as you see, we have to be very highly rugged because we are operating under very harsh conditions. These systems need to be operating in both C, K, and XA. What I'm showing you out here is a complete systems which can have from X band to Ku band to Ka band. C band and X band, and you have also the tri-band solutions. Now, for the interest of the audience, I would say that we have already delivered C and Ku band systems to the Indian Navy. Every Indian naval ship is fitted with a C band and a Ku band. And we have a multi-band capabilities which are given to the many navies in the world. Now, this helps when you have more than one type of satellites, the spectrum. Right now, like GSAT-7 was the availability for Indian Navy, and that's when the project started in 2010. And for the last 14 years, we have delivered more than 250 plus systems which are fitted on various ships and platforms. Now, in case of certain other countries, like what you have in Singapore and Korea and all, they have a multi-band facility. The entire world is already moved to the Ka band because of certain very high features of having a very high throughput. India will have a GSAT-20, which is recently launched, and I'm sure in the next 2025, the armed forces will have the spectrum availability. So the plan is to have a system which is already having it to migrate to the Ka band. So for that, the solution is that we don't have to remove the terminal. We can go into upgradation from Ku to Ka, CKA. So we have the solutions, and it is a proven solution already in the various other navies. This is the presence, just a kind of a number of countries where it's already there in the world, SATCOM systems. Now, we have also come up with a very kind of a specific requirement by the Singapore Navy. They wanted to have a mill-grade SATCOM system because in a ship which has got a very high level of dense environment of many antennas, they wanted to have a mill-grade SATCOM system which is completely having a zero interference from the other systems which are operating in a close proximity. And we have delivered these systems, and we have a patent for this, both C and K bands. You can see that, and we also have in a K band, which basically we call it a commercial K and mill K. So you have all 4 bands systems available on board, depending on the customer to customer requirement. And it meets the mill standards as mentioned above. There are some of the GUIs which becomes very user-friendly. The customer or our local partners who are trained on these systems can operate and make the systems in case of any issues. The very important fact that I would like to share out here is that the next step, which is actually going into a revolution, is the small antennas, which is of a 30 centimeter antenna. I have it on a F7 booth. You can see a small antenna, which can be fitted on a USVs, unmanned surface vessels. And this has been recently been we demonstrated in Poland, where there were 21 navies were there. And the USV can be controlled by using this SATCOM, and it can be, you have no limitation on this. Otherwise, most of the USVs have a limitation of having a secured, or I would say, seamless communication. So this is something, a very small antenna, which is less than, total weight is less than 10 kgs to, including the other LRUs, it will be less than 20 kgs. You can put it on a platform, and we can, sir, any questions, sir? Sir. So we, as I was telling you, these are very small terminals which can be fitted on USVs. And we also have given this solution, and this is what we are talking about. Inmarsat is the constellation which is right now acquired by Viasat. You can call it a Viasat. You can see the uplink and downlink restriction. We have a system out here where we will show you what best we can achieve under the present, atmospheric conditions out here in Delhi. This is the first time that we are having it on a live demo out here. And what is out here, what I'm showing you is AMOS is a Israeli satellite, because of which you can see the data rates are very high. Again, it depends on what kind of a satellite that you have, and what kind of a throughput that you have, and what kind of a beam is being focused on the area of operations. But definitely what I'm trying to tell you is that normally, if you are working with a KU band, vis-a-vis the Ka band, the data rates are 10 times or 5 to 10 times more. So this is a huge advantage when you're working with such small terminals which are handy and which can be used on many platforms. Another very important thing that I would like to put it to the audience is that this system is also been proven on a submarine. It can be put on, because the entire system weight is less than 10 kgs. It can be put on a submarine retractable mast, and it can be used for secure communications on board submarines. And this we have along with our local technology partner, we're in the process of taking this to the next level of introducing it to the Indian Navy, where we can do the trials and do the, give this additional kind of a communication advantage, which is very important for the armed forces. Some of the install base across the world, we're talking about like Italian Navy, French Navy, O3MB network, some of them with the Polish Navy, Indian Navy we have been in part for the last 14, 15 years. It's just these are all communications systems which are been there, and some of the publications in the public domain. Now, I'll quickly shift to the airborne SATCOM. If you have any queries, I'll be happy to answer, or I'll take the questions at the later. Okay, let me move to the airborne SATCOM. The airborne SATCOM is a very interesting field. First of all, the major challenge comes in the airborne SATCOM is certain regulatory bodies who have very high standards of certifications. Unlike maritime SATCOMs, which are, which can go in for any kind of a commercial off the shelf. And these certifications are done by regulatory authorities, which are giving the kind of a, who give the permissions for the particular, the entire aircraft manufacturers are taken. So here the limitation is any small modification or a installation on an aircraft need to go through this kind of a certifications. Unlike a maritime or a, on a land-based thing. Okay. This becomes a huge kind of a requirement. In India, it will have to go in for a semi-lag. The better way is that we can adapt to the already existing standards which have been done by the US, and if that can be accepted, the process will be fast. Now, what do we come with the solution? Where do we see this? We have done over the last more than 2 decades, more than 70 different programs, and we have installed base across the world. And you can see that it is in all kinds of platforms. We have it in transport aircrafts. We have it in mission and ISR, which is basically for the defense. You have it in the, unmanned aircrafts. You have it in VTOL, and you also have a rotary wings and the fixed wings. In India, we supplied a 60 centimeter to Rustum 2 way back in 2014, 3 systems. And thereafter, the project has gone into a different segment. Now it's going to Tapas, and then it'll go. So what I'm trying to say, put across to the August audience, is that we have a solution starting from the 30 centimeter to 46, which are our breast runners across the world. And they give you a kind of a throughput, which I've shown you a few slides ago. And these are all proven solutions and proven platforms across the thing. If you see the platform names I'm mentioning out here with P8I, you see 130s, a King Air, which is also used by by the commercial as well as Dornier, Airbus Euro. We also have that's rotary wings, and Gulfstream 550s. So all the platforms, our systems have all. This is the King Air. The picture that I'm showing out here. With the radome, with the complete solution, it is already there on board all these aircrafts. And what does it consist of? If I give you a little more insight of it, it just consists of 3 elements. One is your main antenna, which I have it on my stall F7. I request all of you to have a look at it. It's a real product, and it is supposed to be for a display. I've taken it, but it can always go on to the aircraft. Okay. And the next one is a KPSU. We call it basically a power supply unit. And why we require this is basically you have it on an aircraft at 28 volt DC. So the 28 volt DC is taken from the aircraft. It is given to this KPSU, which in turn converts to several other power supplies, which powers the antenna. And the last one, which is LRU, is the modem. So modem, we are agnostic. We can have any modem from any of the other companies that we have. And if the customer defined, we are absolutely no issues. And the aircraft is giving you the power supply, and that's it. And in case of your Viasat, we already have a product which is already type approved, and because of it is a type approved, we have the entire thing comes to only 2 LRUs, that is the antenna and the modman. And modman is also the power supply along with the modem. So 2 LRUs, the complete system is ready and live, and you will give the connectivity. This is where I have come to my end of my presentation. Before I end, let me show a small video clipping of a live thing which was done in Poland. So let me turn that. The audio is. This is basically on a vehicle mount, the same 30 centimeter antenna, which you can see, that you can see that it is on an all-terrain road. It's on a small vehicle fitted with the same 30 centimeter antenna, and you are getting a continuous seamless connectivity. So I'm putting across the solution which can be fitted on an aircraft, to the maritime, to the land. We have a proven solution, and it is available. Today we have a system in hand, and we can see the live demonstration in the VIP parking area. I would request the audience to come and have a look at it. And if any questions are there, I'll be happy to answer.